In this lecture, we are going to discuss Ohm's law. So in the last lecture, I told you that if you consider a conductor and if you apply a battery to the conductor, this is your conductor and this is the battery. This side will be positive and this side will be negative. Then I told you that charges will move in one particular direction. Actually, charges which are moving is electrons, but as I already discussed, by convention we will consider that charges are moving from positive to negative and they are positive charges, even though in reality they are electrons and electrons are negatively charged particles which will move from negative to positive. We will assume like this, that charges are positive charges and they are moving from positive to negative. So this movement and the applied voltage, there is a relationship which is given by Ohm's law. According to Ohm's law, at constant temperature, the amount of current flowing in the circuit is directly proportional to the applied voltage. That means the amount of current I is proportional to the voltage you are applying, where I is the current flowing in this circuit. Direction of I is conventionally from positive to negative. This is the statement of Ohm's law. So mathematically I is proportional to V, or I is equal to V by R, where R is a constant called resistance in the conductor. Okay, so here R is a constant which is called a resistance in the conductor. So this is the mathematical equation of Ohm's law. You already studied in class 10, isn't it? Now from this you can define resistance. How can you define resistance? Resistance R is equal to V by I, isn't it? Resistance R is equal to V by I. That means, what is the definition for resistance? It is the ratio of what? Voltage to current flowing through a conductor. This is the definition for resistance, and it is a material property. What is meant by this? If you consider a material, it will have a resistance. If you consider another material, it will have different resistance. So resistance depends on the material. That's why it is a material property. And what is actually this resistance? Resistance is nothing but opposition to electric current. Physically, resistance means opposition to electric current. That means when resistance increases, current decreases. vice versa. Vice versa means reverse. Okay, and the SI unit of resistance is ohm. Its symbol is this one, isn't it? So what is actually mean by this resistance? Let us see. If you are having a conductor and you are connecting it to a battery, then what happens? There will be a voltage, so current will flow. When current is flowing through a circuit means charges are flowing. So when charges are flowing easily means current will be more. Okay, because more charges can flow. If it is very easy, that means more charges can flow. But there will be opposition. These charges are moving, but somebody will be here and they will oppose this movement. They are standing like this. Because of this, the charged particles are not able to move. Okay, your charged particles are moving in this direction, but because of these atomic cores, they are actually atomic cores inside the material. Because of these atomic cores, and those cores are actually in random motion, so that your charges will get collided with the atomic cores. This collision actually creates a resistance. Okay, so your charged particles will get collided with the atomic cores present inside the material, and this collision will create resistance. So resistance is actually opposition. Your charges are flowing, but resistance will oppose this flow. It is just like traffic in a road. If this is your vehicle and you are trying to move in the road, but since so many other vehicles are there, you are not able to move easily. In the same way, instead of your vehicle, electrons are moving, even though their direction will be opposite. I already told you, conventionally we will consider like this. Charged particles are moving like this, but since atomic cores are there, they will oppose the motion of these charged particles, and their opposition is called resistance. Okay, so that is the physical meaning of resistance. So any material, if you consider, it will have some resistance, means it will oppose the electric current flowing through it. Okay, now let us define the symbol of resistance. That means a material which will provide resistance to the conductor is called a resistor. So let us say a resistor, symbol of resistor. What is meant by resistor? A material which will actually put some opposition to electric current in a circuit. Such a electrical element is called a resistor. So symbol of resistor is like this. This also you studied in class 10, and we already discussed that ohm is the unit of resistance. So what is R? V by I. If V is equal to 1 volt and I is equal to 1 ampere, then R will be equal to 1 ohm, isn't it? You can write it in symbol terms also. 1 ohm. So what is the definition for 1 ohm? The resistance of a conductor is said to be 1 ohm if 1 ampere current flows through it. When it will flow? 1 ampere current flows through it if we apply 1 volt across it. This is the definition for 1 ohm. 1 ohm is the resistance of a conductor if 1 ampere current is flowing through that conductor when you apply 1 volt across it. Okay, so if you represent it diagrammatically, if you are having a conductor and you are connecting it to a battery. If you apply 1 volt and you found that current passing is 1 ampere, okay, if this is the case, you applied a battery of voltage 1, then you are getting 1 ampere current, then this conductor resistance is said to be 1 ohm. This is the definition for 1 ohm. Okay. Now what is the dimension for resistance? You are having R is equal to V by I. Okay. What is actually V? V is nothing but electric potential. Potential is nothing but some amount of work done, as we discussed in the previous chapter. So its dimension will be that of work done. And what is I? I is equal to, what is I? I is equal to Q by T. Isn't it? I is equal to Q by T. Sorry, here potential you are having W by Q. So there will be a Q. Now what is I? I is equal to Q by T. So let us write it as I itself, and then we can change it Q, because I is a fundamental quantity. Okay, that will be W by dimension of current is I itself, so we can keep it as I. What is Q? Q is equal to, from this equation you can write Q is equal to IT, isn't it? So I into T. Now dimension of W, what is the dimension of W? ml square T raised to minus 2, you studied last year, divided by current dimension is same as symbol I, there is one more I. And what is the dimension for T? T is time, so dimension for time is T. What you will get? ml square T raised to minus 2 divided by I square T, which is equal to ml square T raised to minus 3, because this T will come here, it will become T raised to minus 1, so T raised to minus 2, T raised to minus 1 will come T raised to minus 3, and I raised to minus 2. So this is the dimension for R, isn't it? Now resistance of any conductor depends on several factors. First one, length of the conductor, L. Second one, area of cross section, A. Third one, nature of the material. And fourth one, temperature, T. Okay, these are the factors in which resistance depends. So if you write temperature dependence, we will discuss after this class, because it is a separate topic. So if you consider the other factors, if temperature remains same, that's what we are discussing now. Ohm's law is valid only when temperature remains same. So we don't need to consider the fourth factor now. If we consider the other three factors in constant temperature case, then we can say that resistance is proportional to L by A. Okay, nature will be considered in this step itself. In the next step you can see nature will be also coming into the equation. So this is equal to, R is equal to a constant multiplied by L by A, where the constant is called resistivity, and this will be a material property. Resistivity will be a material property. So this will be deciding the third case, that is nature. Nature means resistivity will be different for different materials, so rho will determine its resistance in this way. Okay, so you got all the three factors: resistivity, that is nature, length, and area of cross section. Okay, now from this you can write an equation for resistivity also, Ra by L. From this you can find a unit of resistivity. RA by L. So what will be the unit? R unit is ohm, its unit is ohm, area unit is meter square, and length unit is meter. So meter square and meter will get cancelled, you will get ohm meter. So unit of resistivity is ohm meter, isn't it? Now you can define resistivity because you are having rho is equal to RA by L. If A is equal to 1 meter square and L is equal to 1 meter, then rho is equal to R. So resistivity is the resistance of a conductor having unit area of cross section and unit length. This is the definition for resistivity. It is the resistance of a conductor having unit area of cross section and unit length. Now you are having resistivity rho is equal to RA by L, and you also have R is equal to V by I according to Ohm's law. So V by I multiplied by A by L. This is the equation you are having. You can change it as V by L because I am taking L in the denominator of V, and then you can write it as A by I. So this will become V by L divided by I by A. Simple rearrangement only. If you check it in a paper, you will get it. Now what is V by L? We discussed E is equal to V by D. It can be also written as V by L. Okay, so V by L is nothing but E. What is I by A? In the first lecture you can see a quantity current density J is equal to I by A. So this is current density. So you got rho is equal to E by J, or what you can say, J is equal to E by rho, and 1 by rho is called sigma, where sigma is the conductivity. It is nothing but inverse of resistivity. 1 by resistivity is called conductivity. So 1 by rho is sigma. That means you can write J is equal to 1 by rho into E, that is sigma E. Is it clear? So I am giving one more work to you. Find the dimension of resistivity. You must do it yourself. It is a work for you. Okay.